In this video, we're going to talk about if statements. If statements are used in programming when your logic comes to a decision, and code needs to execute only if a certain condition is true. Otherwise, it does something else. On my screen, I have an if statement on line 5. So what happens when the Python interpreter sees if on the screen or in your code? It knows that that's a Python keyword, and what it should expect next is a question. X less than or equal to 4 is a question that's either going to be yes or no. And it's a question because the middle operator is what's known as a conditional operator. Conditional operators are things like less than, greater than, less than or equal to, greater than or equal to, or even double equal for testing equivalence. So we have a less than or equal to conditional operator here, which means this guy is a question. And questions or conditional expressions in Python and in programming in general evaluate to a Boolean true or false. It's the programming language's way of answering the question with yes or no. And this is most certainly the answer no. X is not less than or equal to 4 because we see on line 3 that we've assigned X the value of integer 5. Then the interpreter encounters a colon. And in Python, the colon means that's it. The question is asked. What was the answer? Because what follows next, starting on the next line, is an indented code block that I want you to run if that question's answer was yes or true. So in this case, Python's going to answer that question saying no, false. And the colon says everything that's indented after me, skip it if it's false. Only run it if it's true. So if I were to run this program, the interpreter would get to this line, say, nope, the answer to that is no, it's false. I don't even have to look at this line. I'm just going to skip all indented lines until I see another line at the left margin, and that's where I will continue execution. So running this program, all I should see as output is end of program. And sure enough, I do. Now if I simply change this to a 6, that's going to mean that the if question is now going to be answered with yes or true, which means the colon's going to tell us, okay, next line and every indented line after that, run it. So being that we get a true, our output's now going to say not enough, end of program. And that's what we see as our output. Now I'm going to change this back to a 4 for a minute because now I'm going to extend my question. I'm going to type a keyword else on line 7 following my if code block. So the else needs to be followed by a code block as well, which means I have to indent at least the next line after this. So there I have another code block to execute. If I left this off and tried to run it, actually just let me comment it out, I would get an error because the colon in Python says, no, you're not done your sentence yet. It's like you paused with the comma and never completed it. Just think about in conversation if you said to somebody, hey, if it's raining, and then you never said anything after that. That would be weird, right? Or if you said, hey, if it's raining, take your umbrella. Otherwise, and then you stopped. That's pretty much what you're doing if you don't put a code block after a colon. Okay, so in order to not sound stupid to the Python interpreter, let's finish our sentence. So here our indented code block is saying, hey, I'm a part of this sentence that started on the previous line after the colon, and this is what you do if the first condition wasn't met. So if the question x is less than or equal to 4 is false, do this instead. So that's how this reads to the Python interpreter at this point. So if I run this, my first code block is not going to execute, and because I have an else or a continuation of the logic, this code block will print instead. So I see too much, end of program. Now I actually don't, let's say my logic was such that 5 was the right number. That was what I was looking for. I want to say if I get 6 or more, then that's too much. 5 is just right. Okay, so I'm going to change this now so that, else is going to cover every other possibility that's not x is less than or equal to 4. I want this to be narrowed. I want the scope of this question now to be narrowed down to only if x is greater than or equal to 6. So I'm going to extend the question. So this time I'm going to say, otherwise, if x is greater than or equal to 6. Now, just as a side note, I have spaces in between my conditionals expressions, but Python's okay either way. So if I say x is greater than or equal to 6, I'm asking a second question because elif is not the same as else. If I left this off, it would be an error because the Python interpreter says, wait, else is fine. That means any other possibility. But elif means there's another question coming and you didn't provide it for me. So what we have to do then is provide our Boolean expression or our next question, and that is x greater than or equal to 6? So the way the Python interpreter reads this whole long sentence now is, if x is less than or equal to 4, comma, then print not enough. Otherwise, if x is greater than or equal to 6, print too much. So now we have a situation where this is false, but this too is false. So none of this is going to happen, and we're simply going to see end of program, and we do. But now I want to accommodate the 5. Okay, because if x is not less than or equal to 4 and it's not greater than or equal to 6, there's only one more possibility if it's a whole number. And that would be x must be 5, right? Well, I can cover any other possibility for x with an else. Now, one more time, I know I'm repetitive here, but you have to end each of these with a colon. And following that colon, you have to have at least one line that is indented in for your code block. If you can't think of what you want to be in your code block yet, you can just put a placeholder there that the pass keyword will let you come back to it later and code it later. But you have to have something. So I'm going to make the else code block print just right. And then I get just right, end of program. Now let me show you something if x is equal to 4. It's something that you're not going to see, but something that I want you to understand. I could have accomplished the same thing as this big long if sentence if I had just made all of these if statements on their own. Okay, so I want to show you the difference between the two ways of doing this. And it's subtle, but it's important. All right, so what's going to happen in this code block is this first condition is going to be true. I'm going to get not enough. This is false. This is false. Here's another true. I'm going to get a not enough. This is false. This is false. And then I'm going to get end of program. So I'm going to get not enough twice plus end of program. So let me expand my output window here, and sure enough, that's what I get, 2 not enoughs and end of program. But let me tell you what happened. In this situation, the Python interpreter reads this as one big sentence. And when this was true, it stopped listening. So it didn't even bother or care what the rest of the sentence was. So we saved ourselves 2 processing cycles here because we didn't have to execute 2 more questions. As opposed to down here, where yes, this was true, but the Python interpreter treated each of these as 3 different sentences. So even though this was true, it still had to test. Even though it already knew x was less than or equal to 4, it still had to test this one and this one, which is redundant and unnecessary. So putting your code into if-elifs, if you have a situation in your logic that calls for that, is going to be more efficient than doing it with one if statement after the other. Now I hope that makes sense. But let me show you how this plays out. Let's say that you were grading papers and somebody got a grade of 87. And you want to determine, is that an A, B, C, or D? Now, according to the traditional scale, anything in the 90s is an A, anything in the 80s is a B, C is in the 70s, D is in the 60s. So I could construct an if statement like this. If x is less than or equal to 90, or I should say greater than or equal to 90, oops. It's an A. Now I'm going to run this program. I get end of program because 87 is not greater than or equal to 90. Then if I say, okay, is x greater than or equal to 80? Print B. Let me capitalize that. And sure enough, I get a B. Yay. And then if I make a third statement, is x greater than or equal to 70? Print C. Uh-oh, BC. So this means, because I'm asking one question at a time, that I also have to say, is it greater than or equal to 70, but also less than or equal to 90? So I have to say it this way and put x in the middle. Okay, I'll just say less than 80 because I want it to stop at, say, 79. And then it runs and I just get my B. And then if I want to find out if I have a D student here, I'd have to type it out this way again. And it would be less than 70. Okay, so if I run that, then I get end of program, but then I go ahead and I give this person an A because I curved the test, and now they get an AB, so I have to go back here and fix this one. oops, that's going to be greater than or equal to x, which is less than 90. I run that and they get an A. So now it looks like I fixed everything, right? But if I know the student has an A starting here, is there any other reason to check all these against the same grade? I should just go on to the next score, right? Well, let's change this into an if-elif-elif chain, and you'll see the magic that this allows you to execute. So I'm going to change this to x is greater than or equal to 80. And then x is greater than or equal to 70. And x is greater than or equal to 60. Now if I run it, they still have A, B, C, D because those in-betweens aren't accounted for. But through the magic of if-elif, I know that if this is met, it stops. And if this is met, it stops. And if this is met, it stops. And then if they get an F, I can just say, well, anything else is most certainly an F. So I've covered all my bases. So this is what makes the elif statement really nice from a logic point of view. Also, not only are you saving cycles, but you are also keeping your code cleaner by not having to accommodate that in-between condition. So if I run this now, they're back to only having an A. And if I change their grade to 73, they're back to having a C, which causes this code block to execute, but skips this. So when they had an A, this executed, the rest of this was skipped. When they had a C, this was executed, and the rest of this was skipped. So I hope that you can see how how the Python interpreter can benefit efficiency-wise if you use if-elifs and elses properly. So that's the end of this video. I hope that clears up any confusion, and good luck with your assignments.